Okay, today we're doing Math 6, Mission 5, Lesson 10 and 11. Okay. 10, using long division. Estimate the quotient mentally. All right, so we need to do 500 divided by 7. Well, let's think about this. I know that 7 times 7 is 49. So 490 is very close to 500. So 7 times 7 is 49. So 7 times 70, that does not look like a 70, sorry. 7 times 70 would be 490. So I would estimate 500 divided by 7 is 70 or close to 70. All right, let's try this one. 1,394 divided by 9. Well, okay, remember, we're trying to do this mentally, so I'm just going to throw some numbers out. I know 9 times 100 gets me 900, and that's close to 1,000, but not quite. So let's say we have 390 left, right? 390, somewhere in there. I know that 4 times 9 is 36. So 4 times 90 would be 360, right? So that gets me pretty close to 1,394. Doesn't get me like exactly, right? We're probably about 150 off, but remember, I'm supposed to be doing this mentally, so it gets me close enough. So I would do 900 plus 360, right? Which would get me 1,260, okay? So I would say 1,394 divided by 9 is about 190. It is close. That's what I would say. Yeah, pretty close, right? Oh, sorry, not 190. I took that backwards. I apologize. It would be, because we're doing divided by 9, instead of 4 times 90, it should be 40 times 9, which still gets us 360. So it would be 100 plus 40, which would be 140. That's what it should be. If you caught my mistake before I did, good job. All right, let's go on. Activity 1. Lynn has a method of calculating quotients that is different from Elena's method and Andre's method. Remember, Elena's method from previous times was to use base 10 blocks, right, and divide them up. And then Andre's method was partial quotients. Okay, so now we're going to get a new method from Lynn. We're going to talk about Andre's method, partial quotients, and how it goes with Lynn's as well. But this is Lynn's. So here's how she found the quotient of 657 divided by 3. Lynn arranged the numbers for vertical calculations. Her plan was to divide each digit of 657. So we're dividing each digit. So we're looking at it as a 6, a 5, and a 7. And we're dividing each one of those digits into 3 groups, starting with the 600s. So 3 goes into 6 how many times? There are 3 groups of 2 in 6. So Lynn wrote 2 at the top and subtracted 6 from 6, leaving 0. So then she did 2 times 3 equals 6, and she took that away from our 6 in our original number. And that got her 0. Then she brought down the 5 tens of 657. So she brings down the 5, and that leaves us with 5. Then she asks herself, how many groups of 3 are in 5? Well, there are 3 groups of 1 in 5. So she wrote 1 at the top and subtracted 3 from 5, because 1 times 3 is 3, and she subtracts it from our original number, which was 5, and that leaves her with 2. It's left with a remainder of 2. She brought down the 7 ones of 657 and wrote it next to the 2, which made 27. So here you can see that 27. There are 3 groups. Then she asks herself, how many groups of 3 are in 27? Well, she knows there are 3 groups of 9 in 27. So she wrote the 9 at the top and subtracted 27, leaving 0, because she did 9 times 3, which is 27, and she subtracts it from what she already had, and that leaves her with 0. So she's finished. Discuss with your partner how Lynn's method is similar to and different from drawing base 10 diagrams or using the partial quotients. Okay, so go ahead and think that through. How is it different than using partial quotients? All right, it says Lynn subtracted 3 times 2, then 3 times 1, and lastly 3 times 9 earlier. 3 times 9. Earlier, Andre subtracted 3 times 200, then 3 times 10, and lastly 3 times 9. Why did they have the same quotient, the same answer, right? Okay, so we're going to look at this, and I'm going to use this one over here, and I'm going to do it in blue. So let's do Andre's method here. Okay, so Lynn looked at each digit as a 6, right? 3 times 2 is 6. Then as a 5, right? And she did 3 times 1 to get as close as she could to 5 without going over. And then 3 times 9. So she looked at it as a 6, a 5, and then as a 7. Andre looked at it as a 600, then a 50, then a 7, okay? So like this. Andre said 3 times 200, whereas Lynn only said 3 times 2, because Andre was looking at this as 600, whereas Lynn was only looking at the 6, as just like 6 ones almost. So, and Lynn only subtracted from the digit 6, whereas Andre did 3 times 2, which is 600, and subtracted from the whole number, right, to get 57. Then Lynn did 3 times 1 to get 3, right, and she subtracted to get 20, and then she brought down the 7, 27. Andre did 3 times 10, which got him 30. Do you see how we're still getting similar numbers? And subtracted to get 27. So they both are left with 27. And then they both did 3 times 9, which gets us 27, which gets us a 0 at the end. So they did the same method, just looked at the answers, or looked at the problem differently. Okay? Let's go to the next one. In the third step, why do you think Lynn wrote the 7 next to the remainder of 2 rather than adding 7 and 2 to get 9? Well, that 2 isn't actually 2 ones. Is not 2 ones. It's actually 2 tens, which equals 20. And the 7 is actually 7 ones. 7 equals 7 ones. So if we were to add them together, we would be using this 2 to represent 2 ones to get us 9 ones. But that's not how it is. It's actually 20 plus 7. 2 tens plus 7 ones to equal 27. Okay. All right. Lynn's method is called long division. Okay. Use this method to find the following quotients. Check your answer by multiplying it by the divisor. All right. So here we go. We're going to do the first one. 846 divided by 3. 3 goes into 8 how many times? 3 times 3 is 9, so that's too much. So 3 times 2. So 3 times 2 is 6, and we're going to take that away from 8, which leaves us with 2. Then we're going to pull the 4 down because 3 can't go into 2. It's too big. So we got to add some more to it. So we're going to bring down that 4 to make 24. 3 goes into 24 8 times. 3 times 8 is 24. And then we're going to do 24 minus 24, which is 0. And then we're going to bring down the 6. 3 goes into 6 2 times. 3 times 2 is 6. And we have no numbers left at the end here. And we have a 0 at the end. So we are done. We can stop. So 846 divided by 3 is 282. All right, let's try the next one. 1,816 divided by 4. 4 goes into 1 0 times. 4 goes into 18 4 times. That gets us 16 because 4 times 4 is 16. 18 minus 16 is 2. We bring down the 1. 4 goes into 21 5 times. 4 times 5 is 20. Start track that out. Bring down the 6. 4 goes into 16 4 times. 4 times 4 is 16. 0. So we look. There are no more numbers out to the side here, and we've hit 0 there, so we are done dividing. So 1,816 divided by 4 is 454. All right, now we have 768 divided by 12. All right, 12 goes into 7 0 times. 12 goes into 76. Well, I know that 12 times 6 is 72. So I know that 12 can go into 76 6 times, sorry. So 76 minus 72 is 4. Bring down the 8. 12 goes into 48 4 times. 4 times 12 is 48. So now I ask myself, are there any numbers out to the side here left over? No. And then I've ended with 0, so I'm done. I don't have to continue. So my answer is 768 divided by 12 is 64. So that's how you do long division. Go ahead and review your lesson summary, and then we are headed to lesson 11, dividing numbers that result in decimals. So if you noticed, all of those were nice and even, went in nice and evenly. Now, this lesson, it's not going to, okay? All right, let's do our warm-up. Find the quotients mentally. Gotta love that word. All right, so we're looking at doing 400 divided by 8, 80 divided by 8, 16 divided by 8, which are all things that I can do in my head. And then we get down to here and see 496 divided by 8. Ugh. If you were just looking at the last one, you might think, wow, I don't know how I can do that in my head. But then you look and see that all of these that we can do in our head, when added together, actually equal 496. All right, so let's work through this. 400 divided by 8. Well, 40 divided by 8 is 5, so 400 divided by 8 would be 50. 80 divided by 8 is 10, because 10 times 8 is 80. And then 16 divided by 8 is 2, because 2 times 8 is 16. So then we add those all up to get what 496 divided by 8 would be. So 50 plus 10 is 60, plus 2 is 62. So we could do that mentally. Because you can look at that and say, 496, I don't know what 496 would be mentally. But we know we can do 400 and then 96. And maybe I don't know what 96 is, but I can split it up even more into 80 and 16. And maybe I don't even know 16, so then I break it up into 10 and 6. We can keep breaking numbers down into their parts to figure out an easier way to mentally figure them out or do them. Okay. Alrighty, let's keep going. Here is how Lynn calculated 62 divided by 5. So remember, Lynn did long division the last time in our last lesson. So she was who we're following. So here's how she does it now with decimals. Lynn sets up the numbers for long division. So 62 divided by 5. She subtracted 5 times 1 from the 6 because she knows 5 can go into 6 one time without going over. So 5 times 1. 1 times 5 is 5, and then she subtracts it from the 6 to get 1. She wrote the 2 from 62 next to 1, which made it 12. So she brought down the 2 to make it 12. And subtracted 5 times 2 from the 12, because she knows 2 times 5 is 10, which is as close as she can get to 12 without going over. And then she subtracts it out, and she gets 2. Lynn drew a vertical line and a decimal point separating the ones and tenths place. Okay, so here is our dashed line, right? Our vertical dashed line. And that's saying I am done with whole numbers. Now I'm moving into decimal place value. So she's got the tenths. What I like to do is add a decimal to my number that I'm dividing and add my zeros so that I know, and I'm continuing to still pull down that 0 and help with my placeholders and where to place my numbers in my answer, okay? 12 minus 10 is 2. She wrote 0 to the right of 2, which made 20. So she pulled it down. This is actually not 20 though. This is 0 or 2.0 or 2, because now this 0 is in the tenths place value. But we don't need to write that decimal because we're still looking at it as 20. 5 goes into 20 how many times? Well, it goes in 4 times, but 5 goes into 2 4/10ths of a time. So that's why it is really 2. So here we go. Lastly, she subtracted 5 times 4 from 20, which left no remainder. At the top, she wrote 4 next to the decimal point. So you can see here, she has the decimal point, and then she has the 4/10ths, because 5 times 4/10ths gets you 2. 5 over 1 times 4/10ths gets you, well, 5 goes into 5 once, 5 goes into 10 twice. So that would get you 4 over 2. All right. And then 4 over 2, 4 divided by 2 is 2. So that's where that 2.0 comes from. Okay. So Lynn put a 0 after the remainder of 2 right here. Why? Why does this 0 not change the value of the quotient? Because we have that decimal there. So we can add zeros onto numbers as long as it is after the decimal and after any non-zero number, all right? Lynn subtracted 5 groups of 4 from 20. What value does the 4 in the quotient represent? Well, it represents 4/10ths, right? 4/10ths, or 0.4. What value did Lynn find for 62 divided by 5? So she found that 62 divided by 5 was 12.4, 12 and 4/10ths. All right. It says, use your understanding of long division to solve the following problems. Here we go. So we have 126 divided by 8. So 8 goes into 1 0 times. 8 goes into 12 1 time. 1 times 8 is 8. And we subtract 12 from 8, which gets us 4. And then we bring down the 6. 8 goes into 46 5 times. 5 times 8 is 40. So we subtract that out and we get 6. Now, we have a remainder. We can't leave it like that. So we're going to add our decimal and our 0. And I immediately write my decimal in my answer as well, so I don't forget that. Then I pull down my 0. 8 goes into 60 7 times. 7 times 8 is 56. And that leaves us with 4. I add another 0 onto the end, bring it down. 40. 8 goes into 40 5 times. 5 times 8 is 40. So we subtract that and it gets 0. Then I ask myself, do I have any other non-zero numbers after this? Nope. Did I end in 0? Yes. Then I am finished. The answer is 126 divided by 8 is 15 and 75 hundredths. All right, let's look at the next one. 90 divided by 12, okay? So 12 goes into 9 0 times. 12 goes into 90. Well, you might have to do some guessing and checking, and that's okay. So 10 goes into 90 9 times. So let's try 12 times 8 and see what we get. 8 times 2 is 16. 8 times 1 is 8 plus 1 is 9. Ooh, 96. So now I know I've gone over, but I should do 8 less, which would get me 12 times 7, which would be 84. Right? Because you can just subtract 12 from it, which gets me 84. All right, so now we subtract. This becomes 10, 6, this becomes 8. Okay, now we don't have enough there to have 12 go into it, so we have to do a decimal 0, and then immediately write my decimal in my answer. Then I'm going to bring down the 0. 12 goes into 60 how many times? Well, 5 times. 12 times 5 is 60. Then I ask myself, are there any other non-zero numbers out to the side? Nope. And we've ended in 0? Yep. So we are finished. So 90 divided by 12 is 7 5/10. Okay, 2 says, use long division to show that 5 divided by 4, or 5/4, is 1 25 hundredths. All right, we can totally do that. Here we go. So we are going to do 5 divided by 4. So 4 goes into 5 one time. 1 times 4 is 4, so we subtract that out. That leaves us with 1. We don't have any numbers after the 5, but we have a remainder, so we have to keep going. So we're going to add a decimal 0 and decimal up into our answer. We're going to bring down the 0. 4 goes into 10 2 times. 2 times 4 is 8. And that leaves us with 2. We're going to add another 0, bring it down. 4 goes into 20 5 times. 5 times 4 is 20. And that leaves us with 0. So we can see here that 5 divided by 4 is 1 25 hundredths. Okay? Let's go to the next one. The next one says 4 divided by 5, or 4/5, is 8/10. All right, so let's look. 4 divided by 5. Well, 5 goes into 4 0 times. So that leaves us with 0, because 5 times 0 is 0. So we subtract, bring the 4 down. We have to add our decimal 0. We bring our decimal up into our answer, bring our 0 down. 5 goes into 40 8 times. 8 times 5 is 40. We subtract out, and we are finished. And you can see that, yes, 4 divided by 5 is 8/10. Okay, let's do the next one. So it says 1 divided by 8, or 1/8, is 125 thousandths. Okay, here we go. 1 divided by 8. 8 goes into 1 0 times. That leaves us with 0. Bring down the 1, decimal 0. Bring up our decimal, down our 0. 8 goes into 10 one time. 1 times 8 is 8. That leaves us with 2. Add another 0, bring it down. 8 goes into 20 2 times. 2 times 8 is 16. That leaves us with 4. Add another 0, bring it down. 8 goes into 40 5 times. 5 times 8 is 40, and we are left with 0 and no other numbers out there. So we can see that 1/8, or 1 divided by 8, is 125 thousandths. All right, let's look at our last one. It says 1 divided by 25, or 1/25, is 4 hundredths. All right, here we go. So 1 divided by 25. Here we go. 25 goes into 1 0 times. So 0 times 25 is 0. It's going to save on us for a second. So then we bring down our 1, and we add our decimal 0 and our decimal to our answer. Bring down the 0. 25 goes into 10 0 times. We haven't gotten big enough yet. 0 times 25 is 0. 10 minus 0 is 10. So we bring down the 0 again. 25 goes into 100 4 times. 4 times 25 is 100. 100 minus 100 is 0. We have no numbers out to the side left over, and we've ended in 0. So we are good to stop. So 1 divided by 25, or 1/25, is 4/100. And you can see, yes, that is correct. It's 4/100. All right. Noah said we cannot use long division to calculate 10 divided by 3 because there will always be a remainder. What do you think Noah meant by there will always be a remainder? All right, so let's try this. If we did 10 divided by 3, all right? So 3 goes into 1 0 times. 3 goes into 10 3 times. That gets us 9. We subtract that out and leaves us with 1. So we put our decimal and add our 0. Add our decimal to our answer and bring down our 0. 3 goes into 10 3 times. 3 times 3 is 9. We subtract, that leaves us with 1. We add the 0, we bring it down, that's 10. Do you see a repeating pattern there? If we were to continue to do this, 3 goes into 10 3 times. 3 times 3 is 9, and we get a 1 again. We will always have a remainder. That's what he means. There will always be a remainder of 1 that we cannot get rid of. Okay, do you agree with his statement? Yes. So this is what we call a repeating decimal. And a lot of the times we will write repeating decimals like this: 3 and 3/10 repeated. Okay, that's what that bar means over a number, that number gets repeated over and over and over again. Okay. So when it's something like this, you can write it like this with a bar over the number, or you can write it in fraction form because the fractional form actually does encompass that repeating decimal. So this would be 3 and 1/3. This also happens with 2/3. You get a repeating decimal of 6.6 over and over again for 2/3. All right, go ahead and review your lesson summary.